Okay, so we're going to work on a third formula here, and the part above this line I don't need you to put down on your worksheet. What I need you to put down on your worksheet is going to be below this. But I just want to remind us that we have two formulas that we've created so far: a final position with constant velocity. In other words, how do I find my final position if I have a constant velocity? And then how do I find my final velocity if I have a constant acceleration? Okay, now let's start thinking about what happens if I don't have a constant velocity. What if I have a constant acceleration, but I don't know what that constant acceleration is, but I do know what my initial and final velocity are? So I want you to consider this, and you don't need to draw this part either. I just want you to consider this. What if I have a graph that graphs velocity at each time? So if I have 1, 2, 3, 4, 5 seconds, and I start at 0, okay, and after the first second, I'm now at 2 meters per second. After the second second, I'm now at 4 meters per second. After the third second, I'm now at 6 meters per second. After the fourth second, I'm now at 8 meters per second. And then finally, when I stop accelerating, I'm at 10 meters per second. I've got this graph that shows my velocities. Okay, 2 meters per second, 4, 6, 8, 10. Okay, now hopefully you can see by looking at this graph or just kind of inspecting this graph, if I go from 0 to 10 meters per second over 5 seconds, it will be just like I was traveling 5 meters per second the entire time. Okay? If I go from 0 to 10 in 5 seconds, it will be just like I was going 5 meters per second the entire time. Let's say that again. If I go from 0 to 10 meters per second, let's get rid of this. If I go from 0 to 10 meters per second over 5 seconds, and I do that at a constant rate, it will be as if I was going 5 meters per second the entire time. For half of the time, I would be going less than 5 meters per second. For the other half of the time, I would be going greater than 5 meters per second by the same amount. So just kind of by looking at this graph, I can tell that if I go from 0 to 10 meters per second, I'm going to actually be, it's going to be like I was going 5 meters per second the entire time. Okay, and that would be my average velocity for that time. And so all I have to do to figure out what that is like is add the initial and final velocity together and then divide that by 2. 0 plus 10 is 10, and if I divide that by 2, because I've got two values, I'm taking the average of 0 and 10, and that's going to be 5. Okay, it's just going to be like that. So 0 plus 10 is 10 divided by 2 equals 5 meters per second. Okay, so my average velocity over the entire time is going to be 5 meters per second. Okay, now let's go back then and start with my final position equals initial position plus velocity times time. We don't have our acceleration, and we couldn't just put acceleration in here anyway, but we could pretend that instead of accelerating from 0 to 10 meters per second in our motion, we can pretend that we have a constant velocity of 5 meters per second for the entire time. Okay, so what we're going to do is we're going to say I can substitute 1/2 v plus v0 in for this velocity. Okay, because accelerating at a constant rate is just like going at an average velocity for the same amount of time. Okay, so this is my average velocity, and I'm going to pretend that this average velocity is a constant velocity. And so all I have to do then is substitute this in here, and I'm going to get x equals x0 plus 1/2 times v0 plus v times time. And this is going to give me my final position if I know my initial and final velocity. Okay, so once again, all I'm really doing here is saying that I can pretend that accelerating at a constant rate is just like going at a constant velocity if that constant velocity is the average velocity. Okay, and so we're going to call this the final position or displacement with constant acceleration formula. Okay, so we're going to call this the displacement with constant acceleration formula. And we're saying acceleration because the average velocity for the acceleration is just like what happens if we have the acceleration. Okay, I'm not really doing anything differently. I'm just spreading it out over the entire time, saying I'm going a constant velocity of the average velocity. Okay, so even if you're not quite clear on this, let's go ahead and use this formula and go ahead and look at the next formula.